Hello, everybody. My name is Melissa. I'll be the host today. And today we are going to be talking about the 2 decades of automatic detection and avoidance of drilling hazards with artificial intelligence. I would like to present to you guys our presenters. So first we have Ji Kao. So Ji holds a PhD in oil and gas engineering, and he has 10 years experience in R&D in well modeling and predictive analytics and optimization. He's currently focusing on drilling and digitalization and automation with digital twins and AI. And Joseph Nabavi. So Joseph holds a master's degrees in industrial asset management, and he has 10 years experience in IT systems with emphasis on digitalizing drilling and well operations. I will then give the floor to G, and he will start with the presentation.
Okay, thanks, Melissa, for the introduction. Good afternoon or good morning, everyone. Welcome to our Avoidance webinar. Today, we are going to talk about our experience in automatic detection and avoidance of drilling hazards with artificial intelligence. Before that, I would like to have a quick review of eDrilling, the company's history. So eDrilling actually dates back to the research inaugurated at the Rogaland Research in 1989 here in Norway, with the main R&D projects on advanced drilling modeling, model-based reasoning. The eDrilling idea started from 2004, and the company was formed in 2008. When we first launched Well Ahead in 2008 for real-time drilling engineering, and also we produced a lot of other products like Well Balance for managed pressure drilling, and Well Sim for drilling your well on the simulator, and Well Planner in your planning phase to optimize your drilling plan, and also a 3D visualization engine, a well map, to help you visualize and navigate your well in the visible subsurface. In recent years, we more focus on the scalability and the deployment of our products on cloud architecture without getting rid of your legacy system. So microservice go to market in 2021, and we also have a new product called Well Guide last year, ready for you to optimize your real-time operation like drilling, tripping, lowering strings, etc. Besides, we also launched a project funded by government and together with multiple collaborators from oil and gas companies, service company, and drilling contractors to develop well control technologies specialized for CCS wells as part of our dedication to reduce carbon footprint. So our software has been used by more than 6,000 users across 20 countries for more than 15 years. And the successful rate is, we are proud together with our customer to see it's 100% successful rate. So that's a quick summary for the eDrilling, the company. And next, I would like to have a quick overview of the products eDrilling has. With more than 2 decades R&D, now eDrilling has a suite of drilling software for the whole life cycle of drilling process, from planning, preparing, to executing and reviewing. Those different pieces of software aim to meet different challenges in various drilling phases using unique state-of-the-art technologies from eDrilling. Today, our main focus on hazard detection and avoidance will be using the software called Well Ahead in the middle, showing in the middle. But of course, if you are more than welcome to ask for a demo about other applications if you are interested. So next, drilling hazards, of course, as we all know, are the most unwanted situations during operation, which might lead to severe problems or disasters and increase the expense due to MPT or remediation operations. So to reduce or avoid that, the main technology behind our software Well Ahead are 3 cornerstones as listed here. First is the dynamic transit modeling, which combines the thermal-hydraulic wellbore modeling with the torque and drag model, which embedded with an ROP, theoretical ROP model. So based on those dynamic modeling, we have built a digital twin together with real-time streamed data from the rig. And also in terms of detect the potential events or hazards, we used model-based reasoning, a part of the AI technology, to detect the anomalies from what we observed from the actual well or actual rig with the predicted behavior from our digital twin and modeling. Based on this comparison and detection of the description, we would detect potential anomalies or hazards that we might encounter in the near future. So all those three main technologies enables us to do a lot of job like automatic detection, diagnostics, predictive analysis, and analyze what-if scenarios, and also forecasting your trading performance. So that's the main technology we have been using in Wellhead. Next, more specifically in Wellhead, it helps us to automatic monitoring and do the predictive analysis, such to avoid hazardous incidents, to reduce or avoid rig downtime, and to make more informed and better decisions. As shown on the right figure, the top one is the 2D view of our software layout, showing the monitor data together with the model results. The diagnostics and warning messages will showing up when they are triggered. Meanwhile, it also to have a 3D visualization along your well trajectory, as shown in the bottom figure, along your trajectory in the whole field, in the subsurface, make visible. So that's mainly Wellhead we used for today's topic. And this software and technology has been there, as I mentioned, since 2008. And right now it has been applied cumulatively to more than 420 wells. Of course, here, as showing the figure, different colors represent different types of wells. And it all includes onshore and offshore wells, from fixed or floating rigs, and complex wells, even factory wells. And those are applied globally in more than 20 countries. So that's the main customer success story. And next, I would like hand over to our expert Joseph to talk more specific examples of how we help customers to avoid hazards or incidents and increase the trading efficiency. So, Yusuf.
Thanks, Jay, and hello, everyone. My name is Joseph, and I'm going to to share with you some actual examples on how Wellhead reduce incidents and NPT, increasing the safety of the well and its efficiency, and reducing carbon emissions and costs. Before I go through avoided issues by Wellhead, I would like to shortly introduce our Wellhead product. So what is Wellhead? Wellhead is the product for real-time automated monitoring, real-time analysis, and live well support for different kind of operations, from drilling to tripping and cementing operations. How can Wellhead be, maybe someone is interested, how the product can be deployed actually? Is it feasible in my current environment, and so on, this kind of things. So Wellhead actually can be deployed in both cloud environment and edge environment. It can also be deployed on local on-premise installation. In addition to that, if you don't have this kind of solutions yet, so you can, of course, install the Wellhead in your local computer and PCs as well. So that's about the deployment of Wellhead. Short about what is needed to run Wellhead. So the input data to run Wellhead, it's divided on three. We can divide it on three parts. The static input data, the semi-static, and the dynamic input data. So the static input data, it includes pressure profile, temperature profile, land survey, PHAs, formations, and wellbore geometry. Those are the static data, which does not change. You are planning to use this PHA, this wellbore geometry, and then you use that. And then the semi-static data is the mud properties. Some part of mud properties are static, but the other parts like rheology, gelling data, and then density, sometimes the temperature, the mud temperature that you are pumping in, those parameters, they are changing during real time. So that's why we call it semi-static data. And then when it comes to dynamic data, Wellhead receive the dynamic data through WITSML from the rig side during real-time operations. It includes like bit depth, well depth, block position, ROP, hook load, flow rate, standpipe pressure, RPM, and weight on bit. So that is the different type of inputs Wellhead needs, actually, what Wellhead received to create a digital twin of the well that you are drilling right now, and then based on that, give you suggestions and then improvements on your operation. The modeled data, again, the modeled data, you can visualize or plot it in different ways as well. As you see on the screenshot here, this is our internal software that you can use as a visualization tool, as a plotting tool. So either you can use this, or you can use a third-party tool that you can visualize our software. For instance, you can use Kongsberg Discovery Web to visualize our modeled data together with all the measured data. So when I'm going through some of the examples now, so you will see that we have used the Discovery Web to visualize our data. And these examples, before I go through the example itself, as you see, this layout, this is from the Kongsberg's digital discovery. So they are using our modeled data to visualize on their side. So then it's used by the customer. And this well, it has been drilled, as you see from the depth, in 2021. The depth is 3678 meters. This is the depth which the warning and notification has been generated. So what was the notification? Calculated ACD above fracture pressure. This is automatic warnings that the wellhead, in case of abnormality, so the wellhead generates automatic warnings and send it to the customer. So what was the risk? The risk was early you are above fracture pressure, and you probably are going to loss situation. The recommendation by the SEF was reduce the tripping speed. As you see on the big spikes on the ECD, on this area, so as you see, a very big spikes on the calculated ESD during run hole with a web store. So to make the story short in this example, so the sections, there was wider sections above 958-inch liner, and then there was a 958-inch liner in the lower part. So when they were running in a wider area, so the pressure and everything was fine. And once they have entered the 958-inch liner with the wipe saw, so then you see a very big spikes on the pressure. The system generated an automatic warning, and based on that, the rig personnel, they checked, okay, what's going on. They checked this one, and in addition to that, they recalculated the active pits on the rig side, and they observed some small losses as well on the rig side. Based on that, so they tried a couple of more stunts with the same planned speed which they had, and then they observed some more losses. And after that, based on wellhead calculations, based on wellhead optimization of the tripping speed, they reduced the speed, and then there was no losses. So in the worst case, if they could continue with the same speed, which they did planned in the prehand, so they may face severe loss or a total loss in the worst case. In the next example.
One moment, Yusuf. We have got a message about not having sound. Could the other attendees please just send in OK thumbs up if you can hear us well, so I'll know. Okay, thank you. You can continue.
Yeah. On the next example, if you go to the next one, please. Thank you. This is a Motherwell which has been drilled on the North Sea as well. They drilled the well. The story of this well is that they drilled the section. They pulled out the BHA. They knew that the formation was very unstable. The whole condition was not perfect. And based on that, they decided to pump down or ream down the liner in the open hole. This case is a run hole with liner in the highlighted area in number 1. As you see, the pink one is the modeled SPP, and the green one is the measured SPP. If you see the measured SPP, is start decreasing, and at the same time, as you see, so there was an automatic warning on the right-hand side, as you see on the right-hand side of the screenshot of the plot. So unexpected decrease on measured SPP. That has been generated automatically due to reduction in the measured SPP. But since the operational team, they were very busy with the other parameters like hook load, friction on the well, they didn't realize that the standpipe pressure is decreasing at all. So even though there was an automatic warning here, so they didn't recognize, they didn't check anything after that either. And therefore, we had to communicate with the drilling superintendent. And then he asked the operational team, the drilling team, the drillers team, to check what's going on with the standpipe pressure. And when they checked, there was a leakage on the sewer set. And then at this area, the area that is no operation, no tripping. So they fixed the sewer set, that area. And then after that, they start washing down or reaming down the liner again. As you see, the SPP is normalizing back. The feedback from the drilling superintendent in this case was that if you could continue with the same thing without detecting the leakage on the standpipe pressure properly, you got stuck with the liner at some point, and then you had to redrill the section, basically. Yeah, and the next one. There's another case. So this one, as you see, this one is we have used, the customer have used our plotting tool here. So they decided to use our plotting tool directly without plotting our modeling data in a third-party software. So this one, the section was drilled. That was the reservoir section. They had to take some pressure points in the sections during pull-out of hole. In this area, on the highlighted area number 1, this is the modeled ESD during pull-out of hole. When they did pull-out of hole on those two areas and some area above that, which is not presented in this slide. So there was some automatic warning that your ESD, your well pressure is below collapse pressure during pull-out of hole. After that, they just continue on the next stand. They didn't, okay, maybe when they checked the automatic warning and we discussed with the rig team, they said maybe the software is too sensitive. And then they continued the next one as well, couple of some more stunts with the same speed, and there was some more news automatic warnings. And afterwards, when they tried to take pressure points and pull out a full, so they see some spikes on the standpipe pressure as well. So it was showing that the whole condition was getting worse and worse. So the conclusion was that, based on our discussion with the rig team, was that they were probably pulling out a full too fast, and they were taking too many pressure points. And based on the software detection, they decided to do two things. The first thing was to reduce the pull out of full speed, and the second thing was to reduce the number of pressure points in order to not stress the formation more. On the next one, it's another, it's not, this well was not in the North Sea, it was somewhere else in the world. So this is, there are available time-based plots as well, but to just, since we don't have much time here, so I just put it the roadmap, the automatic real-time roadmap here. So well ahead, you create a hook load roadmap during real-time operation. So the system detects your hook load during tripping in, drilling, and tripping out, and reaming operations all the time in real time. So in this case, so they were pulling out a full with the BHA. The section was drilled. So the first points, the red dots, as you see on the right-hand side, so they are which are not highlighted. The first one on the right-hand side. So they are the first pull out of full points, which is showing a much higher friction on the well when they pull out a full with the BHA. When they pull out a full, when they were finished with the pull out a full, they have been suggested that based on automatic roadmap, we see a very high restriction, high friction on the well, and it's better that you run a wiper trip before you are running the liner. So they run a wiper trip, and then as you see, the highlighted points are the pull out of full points with the wiper trip BHA, so that the whole condition is much better. And then after that, they run the whole with the liner without any issue. So this was the examples on how well ahead avoiding issues, and based on that you can save time, your drill, your well safer and faster. And by that, when you are drill, you are well safer and faster, you reduce the carbon emissions and save money as well.
Yes, thank you, Yusuf. Now I'll be taking in questions for the chat. So you guys can write any questions on the Q&A tab, and I'll be reading them for you. Okay, we have one question come in. Thank you, good presentation. What is the AI job here? Asking this because it seems as normal alarm system based on parameters alarm setup. I guess, G, if you would like to answer this one.
Yeah, sure. Thanks very much for the question. It's very good spot on this. So I should first explain AI has a large range of areas from expert system, model-based reasoning to machine learning, deep learning, reinforcement learning, etc. So this is not just machine learning to predict whether there is a stack pipe or something, that type of AI, but AI in expert system that we call it specifically model-based reasoning, by comparing the modeled data with the real-time observed data, and to have some detection of the anomalies and reasoning for what would be happening the next. That's part is the AI job doing here in well ahead. So put it simply, you can understand it as a reasoning system. It's rule-based reasoning, and also like expert system.
Thank you, G. Let me see here. So another question, how do you detect activities using decision tree? Joseph, if you'd like to take this one.
Yeah. Yeah, activities. There's a model inside our system which is detecting the different type of operations. Let's say that you are drilling, tripping, or doing cement job. There are depends on what you are, what is going on the operation. Are you pumping? Are you reaming? Do you have rotational speed? And then there is a very advanced algorithms inside which, if I call the model OSM, which is detecting those kind of signals. It's high advanced algorithms there, which is detecting the different type of activities during different type of the operations.
Yes, thank you, Joseph. Another question here. Is it a bot analyzing real versus modeled data? Joseph, you can take this one.
Yeah. Yeah. Let me. There are. As explained, so the modeled data is based on a digital twin, and there is a diagnostic model, which is always analyzing those two parameters. If there are some abnormality, it's giving automatic warning. Yeah, this is done automatically by the diagnostic model.
Yes, thank you. Another question from Saleh. I want to ask, how do you get all the data from rig site? Is it from drilling sensors or from service contractors' sensors?
It is true with SIML, but the system is able to check from the other sources as well. Normally, we receive the data from with SIML from different contractors, let's say Schlumberger, Halliburton, and Geolog, and other providers.
Thank you, Joseph. Another question. So how to read integrate with rig real time? I guess you already answered that, right? Through XML. Yes, go ahead.
Yeah, that's what that was the answer for that as well, I believe. So all the real-time data that is coming from the rig site, from different any provider you have on the rig site. So we are receiving those signals, those real-time values from those sensors, and then we are using that to calculate, to create a digital twin.
And do you want to add anything, G? Yes.
Yeah, back to the question. The sensors is actually not from eDrilling; it's from other contractor sensor. So we have the data using the WSML format directly streamed with our URL, and of course with also username and password. It could be plotted in wellhead in our software interface together with model data. And also our software is compatible with third-party tools like as Yusuf showed, it could be visualized in Kongsberg Sitecom or Discovery Web as a third-party tool. So we provide the calculated data, so it integrated in the third-party visualization tool.
Yes, thank you, G. I think that was the last question. So I will be finishing the webinar here. Thank you, everybody, for joining us in the webinar. Any questions, you can send it into info@eDrilling. And if you'd like to watch the webinar again, you will be able to find the video in our YouTube channel, as well as a file with the questions that we weren't able to answer. Thank you very much and have a nice day, everybody.